Hi, in this video I want to show you how to do multi-environment deployments to a Kubernetes cluster. So what we will create in this video a number of targeted Kubernetes targets in Octopus that have user accounts that limit them to a particular namespace, and we'll use that namespace as a way of creating the environments within a Kubernetes cluster. We'll also create a number of runbooks that we'll use to manage and report on the cluster. And in this way, we'll have a nice set of automated tools that we can hand over to whoever takes control of the deployment process once we're done here. These people may or may not be Kubernetes experts, but with the set of runbooks that we create here, they'll have a good footprint for managing the deployments in future. So to start with, we have a single deployment target already set up. So this is a Kubernetes target created, a Kubernetes cluster that has been created in Google. And the authentication here is the admin account that gives it global access. And so we've given this the target role of admin K8s to indicate that administrative tasks that are cluster-wide should be run against this target. And so the Kubernetes target that we're looking at is this one here. So that's the 124 IP, and that's the 124 IP there. So what we need to do, because we don't want to do all deployments through a target that has global access to the cluster, is create a number of more specialized targets. And so these targets will have accounts or service accounts that are restricted in the namespaces that they can deploy to. And so, for example, we'll have a service account targeting the development namespace, a test account targeting the test namespace, and a production service account targeting the production namespace. And that way, any deployments to development, for example, simply won't be allowed to access anything in test or production using the Kubernetes role-based access control. And so to do that, we'll make use of a community step template. And we'll run that step template through a runbook. And the step template is called create targets. It's this one here, sorry, create service account and target. So we'll add that. We will be running this against the admin role. The admin role is what we need to grant access to the particular service accounts in the first place. But the targets that this step creates will be given the role of just K8s. And it is this role that our deployments will target as opposed to the admin one above. The namespace that the Kubernetes targets and service accounts will be directed at and limited to is the lowercase name of our environments. So I'll save that and run it. We'll just run it against our three environments: development, test, and production. And we'll wait for these three to create the various Kubernetes resources and the targets in Octopus. So I should point out that the environments that we're creating targets in have been pre-configured to allow these dynamic targets to be created. And that is done through this option here, dynamic infrastructure. So we've created these environments and ticked this. This option is not enabled by default. And if this option wasn't enabled, the step to create the targets would fail. You just wouldn't have permission without that option selected. So if we go back here, have a look, it looks like we've successfully created everything. So let's have a look at the development deployment. What we can see is that a service account has been created. In this case, it's called development deployer. A role and a role binding have been created, and these will expose access to the development namespace and link the role to the development deployer service account. So in this way, this account only has access to the development namespace and no others. We then created a token account in Octopus, and we'll see that later. And then we created a target. And this text here is the health check of the newly created target. So if we look in accounts, we'll see 3 new token accounts. These token accounts represent the service accounts that were created in Kubernetes. And if we look at deployment targets, we'll see another 3 have been created: development, test, and production. If we look inside, we will see that they're mapped to their particular environment. They've used the token account that represents the service account that limits them to that environment. And they've set a default namespace here to that environment. And so this Kubernetes target in Octopus effectively represents a security boundary. Deployments to this target can only happen to the development environment and not outside of it. And Kubernetes will ensure that that is the case based on the limited access that this service account provides. So with those targets in place, we can go ahead and create a deployment in Kubernetes. I just want to call out here that I've created a variable called environment. We'll see the value of this variable displayed inside the web application once it's deployed. And the values that I've assigned to this variable have been scoped to individual environments. So when we deploy to the development environment, this is the value that our Octopus environment variable will get. And we'll see that in action once the deployments have succeeded. So to actually deploy a image to Kubernetes, we'll use the deploy Kubernetes containers step. Contain, which is this one here. And so this is an opinionated step that provides a high-level user interface over the resources that we'll be creating in the Kubernetes cluster. And in this case, we'll be creating a deployment resource, a service resource, and an ingress resource. And these deployments are going to go to our restricted targets here. So we use the K8s as opposed to the admin K8s. We do want to create a deployment. We will call this random quotes after the name of the application that we'll be deploying. And we will expose the container. So we'll call this random quotes as well. Quotes. And that's the name of the container on Docker Hub. So to access this container, we do need to expose a port. We'll call that port web, and it is port 80. Now to show off the variable management, we'll create an environment variable inside this container. And this environment variable is going to set the name of the active Spring profile. So this is a Spring Boot application that's been containerized, and we've made the assumption that the name of the Spring profile is also the name of the environment that is being deployed to. So we'll set that to environment. Now, to expose the pods created by this deployment, we need to have a service, and that's done under this section here. We'll just call this service. It only needs to be accessible inside the cluster, so we'll use the cluster IP service type. If we wanted to expose this, the pods directly outside, we could use node port or load balancer, but we'll actually be accessing these pods through an ingress controller, which gives us control over managing the mapping between an incoming host name and the responding service. So to expose the web app through a service, we just need to set up the port. And again, we'll just expose port 80 through the service and direct it to port 80 in the pods. So to get our external access, we'll use an ingress. And the ingress here will map incoming requests based on host name. What we have here is we're saying any host name that is the lowercase copy of the environment that we're deploying to at octopus.tech will be mapped to the service we just created on the root path. Okay, so let's save that and run the deployment. So what we can see here is the deployment is going to the development-k8s target, which is that limited access target that we created that only has access to the deployment namespace. If we look at the verbose logs, we can see the resources that have actually been created. So if we go down here, we can see that the deployment resource has been created. This is the Docker image that we're using, and we expose port 80. We can see the environment variable that we defined and the value that was assigned to that variable for this particular environment. We can then see the service that was created, exposing port 80, and then we go down and we see the ingress that maps this host name, development.octopus.tech, to the root path of the service called service, again on port 80. So that deployment went through, but we don't actually have an ingress controller installed in Kubernetes to manage the external connections. So we have no public access to our pods at this point. So what I'll do, just to make sure that the pods have deployed properly, is use another runbook. Call this get pods. And our process in here will take advantage of another community step template. In this case, it's called a Kubernetes inspect resources. And this step template is a convenient wrapper around calling kubectl. It means that anyone who has access to run this runbook can inspect the contents of a cluster, and they don't need to have kubectl installed locally, and they don't need any credentials configured locally either. It's all run through Octopus. So what we'll do is we'll get the pods, and we will create an artifact. And so this is just a text file that shows the output of the kubectl command, and sometimes that's easier to look at than the raw logs in the Octopus output. So we'll save that. Now what we will do is just limit this to the development, test, and production environments. We don't expect to be looking at pods in any other environment for this kind of work. So that means we won't be using the admin environment here. So let's select the development environment and click run. What we will see in the logs are the kubectl commands that were run. In this case, it's simply kubectl get pod. We can see that our pod was indeed created and is running successfully. And that same information has been captured in a text file that is an artifact of this particular run. So to get access to our pods externally, we need an ingress controller. So Kubernetes supports many types of ingress controllers. Many third-party products provide that functionality. And we need to install one in order to do that, in order to have the rules of that ingress object turned into a real networking that we can use to access our pods. And what we'll do there is install the Nginx ingress controller. And we'll do that through a Helm chart. And the installation of the Helm chart will be done through a runbook. And so we'll use the upgrade a Helm chart step. Because this is a cross-cutting action, the ingress controller is shared between all environments. We will use the admin controller, sorry, the admin target for this. Now the Nginx Helm chart comes from a Helm feed that I set up earlier. If we just search for Nginx, we'll see the ingress control package chart that we need. And we'll give this the name of Nginx. We'll give this the Helm release name of Nginx. Now, one thing we do need to do is give this step access to a Helm version 3 executable. The worker that we would normally run this on doesn't have Helm version 3 installed. But what we have done is uploaded Helm here. And so this file here is the result of downloading the Windows executable here from Helm releases. And inside, for the executable location, we need to give it the location inside the artifact where the Helm executable can be found. And it is found under this directory here. So if we look at the download, which was this one. So this is the file downloaded from Helm. We can see the Windows AMD 64 directory is where the Helm exe is found. And so that's represented here. So let's save that. I'm just going to go to the settings and say that this should only be run in admin. It doesn't make sense in other environments. So when we run, we'll get the only environment available to us already selected. And we click run again. We'll install the Helm chart. So here we can see the Helm executable has been downloaded to the worker, and the upgraded Helm chart will make use of that executable, the helm.exe that we pointed to perform the actual upgrade. And so here's the end result of deploying the Helm chart, and we can see that it has gone through successfully. One of the things that the ingress controller creates in order to respond to external traffic is a load balancer with a public IP address. And what we will need to do is get that IP address so we can properly map the DNS entries, allowing us public access through a friendly name, and also allowing us to map those host names that we created in the ingress resources. So what is the IP address? And this is another case where we will use a runbook to query the cluster in order to find the information that we need. So we'll call this get ingress IP. And again, we will use the community step template to inspect resources. Again, because we're working with a cross-cutting resource here, we'll use the admin target. We do want to get the details of service, and in this case, we want to describe the service so we get access to the more detailed information. And again, we'll create an artifact here so we can view that as a plain text file if we want to. This also only makes sense to be run in the admin environment, so we'll limit that scope, and we'll run admin is pre-selected. So let's run the runbook. Okay, so if we look in the logs here, we can see our services, one called Nginx Ingress Controller, and the other one called Ingress Default Backend. And this is Ingress Default Backend that we're interested in. This is the one with the public IP that we need to access. And the detail, the actual IP address here is this load balancer ingress. It's 3470, 120, 140. We can actually go and verify that by looking at the services through the Google interface. And there it is there. 30, 70, 120, 140. So that's the IP address that we need to map to our host names in order to get access. So to get access to, to configure the host names, we have a DNS name here. a wildcard address, octopus.tech, and it currently has a dummy value of 1.1.1.1. And we need to map that to the IP address of our public load balancer. So I'm going to grab that. And inside Octopus, I do have a runbook already configured called update DNS. And this is running a curl script against simple DNS, which is our DNS provider. It's pre-configured with the details of the particular DNS record that we need to modify. And in this case, the IP address that's going to be assigned to that host name comes from a prompted variable. So if we run this, we paste in the IP address of our ingress public IP, sorry, the public load balancer, and we run that. We will see, I've used curl here, I've uploaded that as a package to the built-in feed, and then just downloaded it as an additional reference package. So that means we can be assured that the worker that is executing this step has access to curl. And there we go. So the result has come back as we expect. And if I refresh the page here, we have assigned the IP address to our host name. So all that's left now is to go to development.octopus.tech. Okay, so what's happened here is that the security, the certificates associated with our ingress controller haven't been set up properly. And so Firefox has prevented us from accessing that site. So what we need to do here is assign a proper HTTPS certificate to our ingress controller to allow this action to proceed. And to do that, we go back to our random quotes and we will edit the ingress resource. So if I scroll down here, what we need to do is define the ingress TLS. And so I have already uploaded a certificate. It's a wildcard certificate for this particular domain. And the host name that we want to assign this certificate to is the same, lowercase version of the environment name, .octopus.tech. So let's save that and redeploy. If we look at the verbose logs, we'll see some additional resources have been created as a result of configuring those TLS settings. So the first one is a secret has been added, and the secret is called this. And so the secret contains the details of the certificate that we're using. And the ingress resource now points to this secret in the TLS settings. And so this will map the contents of this secret, which is the certificate, to this host name. And so that went through successfully. And as we can see, we now have secure access to the website. So if we look here, we can see that the certificate is the one provided by Let's Encrypt. You'll also notice here that this application now puts the name of the Active Spring profile to this text here. And this text here, which is this is the development environment, is what we sourced from the value of this variable. So we've successfully deployed to the development environment. Let's go ahead and deploy to test. The name of the target has changed. We're using test-k8s because that is the Kubernetes target that was assigned to the test environment. If we look at the verbose logs, we will see the same selection of resources being created. We have a secret, we have a deployment, we have a service, and we have a ingress. And all the templated variables have been replaced as we expect. So the host name has changed to test.octopus.test. And if we load this up, we will see that the variable that we assigned to the test environment is now displayed here. I'll just go back here to confirm that it hasn't overwritten anything. It hasn't. That's still the same old, the same text that we saw before. So the last step is to push to production. And we'll assume that works and check it out later. So one thing I do want to point out is that the reduced scope of the individual Kubernetes targets means we do prevent people from contaminating other resources. So what I'll do here is manually set the namespace that I want to deploy in. And so this will override the value that is defined in the Kubernetes target. And the end result is that actually every deployment to every environment will try to be created in this namespace. What we want to see here is this should fail. The deployments to the K8s targets, or the targets with the K8s role, should restrict us from breaking out of the namespace of that target. And here we go. Our user was forbidden. We don't have access to the to that particular namespace, and we've been prevented from a misconfiguration corrupting or perhaps overriding values in namespaces that it shouldn't. So what have we achieved here? What we have is we now have a dashboard that shows us the progression of our deployments. We can see the success or failure of any particular deployment. We have a number of deployment targets that have limited scope and will prevent any misconfigured deployments from reaching outside of the namespace that represents their particular environment. We also have a number of useful runbooks that we can hand over to whoever will be supporting these deployments in future. And so what this means is that people can run these runbooks with a high degree of certainty that they will achieve, or they'll return some useful information, and no one needs to have any local configuration of credentials or even the kubectl tooling available to them. They simply need to go through the web interface and run the runbooks. Something that I will point out is that we've defined the settings for all these Kubernetes resources through a like a UI-based approach. But if we expand this edit YAML section here, we can see the Kubernetes YAML that you can use to deploy this outside. So what this means is that if you've found a particular setting that this step doesn't expose, you can take these, you can take the values in the YAML format and migrate them over to a more generalized step like the deploy raw YAML step. Which is, let me do a better search, YAML. Deploy raw YAML. And so at this point, you can copy and paste, and the migration out of that opinionated step is made very easy for you. The other thing to note is that, I'll just delete that one, is that this YAML is editable. So if I get rid of that, let's make replicas 3. And we go into our deployment, we'll see that the number of replicas has been updated to 3. So it's a two-way sync. And if you're more comfortable editing YAML and you find that quicker, then that's certainly an option for you as well. So I hope that demo has been useful. Before we sign off, I'll just make sure that our production deployment worked. Yep, finally in production. And if you have any questions, please leave a comment on the associated blog post. Thank you, and see you next time.